Welcome to Chapter 9, Section 7, entitled Similar and Congruent Figures. All right, to begin with, figures that have the same, figures that have the same shape, but not necessarily the same size, are called similar figures. So, quick example. There's a right triangle. There's a right triangle. They are the same shape, but they are not the same size. Figures that have the same shape and size are called congruent figures. Sorry, that's the word size. So basically, let's see here, let's make a rectangle. There's a shape, and this is a congruent shape. They are exactly the same shape and exactly the same size. So the question, and write it, are all equilateral triangles similar, congruent, both, or neither? Let's take a look. Here is, I think I can make an equilateral triangle. There's an equilateral triangle. There's an equilateral triangle. So by looking at these two examples, are all equilateral triangulars similar? They all are similar. They are not all congruent. They aren't both, or they're neither. They are all similar because all equilateral triangles have the same shape and the same angles. Okay, all equilateral triangles are 60, 60, 60. The only thing that's different is the size. So everything's the same about them. In size. All right. So all we have to do is look at this and tell whether each pair of figures is similar or congruent or neither. These are similar, not similar. Similar because same shape. Different size. Looking at these, are they similar, congruent, or neither? This one is neither because they are different shape and different size. All right, let's take a look at these. Hopefully after watching these two examples, you can take a look at this and right away determine that they are neither. Because again, different shape. They are a different shape. Here. Now it's very hard sometimes to see if they are similar or congruent, but hopefully you see that this one and this one, they are the same shape. But they are different sizes. So when they're different sizes but the same shape, you're dealing with same shape but different size. You're dealing with something that is similar but not congruent. All right. The sides of similar figures that match are called corresponding sides. Take a look at this last example of being similar. this side right here matches or is corresponding side right there. The longest side of this triangle is right here. The longest side of this triangle is right here. Those are corresponding. This side here corresponds with this side here. And it's very important to be able to tell the difference between, determine which ones are corresponding sides. All right, because you use this when comparing. Skateboarding ramps. The two ramps shown are congruent. So if they're congruent, then we know that this side right here is this side right here. We know then that this side is this side, and the next longest side right here is right there. So, what side of triangle QRS corresponds with AC? Well, corresponding sides represent the same side. So AC was in blue, A to C. So that means QS corresponds to AC. The two floor tiles shown are congruent. What side of rectangle ABCD corresponds with FG? So let's set this up. Let's do the color coding. We know this side and this side are equal. We know this side and this side are equal. So the question is, which side corresponds with FG? So FG is this red side here, and it corresponds with BC. All right. Now, identifying similar figures. Which rectangle below is similar to rectangle EFGH? All right, so similar means same shape. The size doesn't matter. So any one of these, just looking at the size, could possibly work. And I want you to add this part to your notes. To determine similarity. To determine similarity, you have to write, or I should say compare proportions. Compare proportions of corresponding sides. So we're going to compare FG and FG and BC and FG and NO and FG and XY, and we're going to compare them to some other things here. So let's see, let me move this. All right. So we're going to look at HG. HG is 4. DC is 3. And now we're going to compare it to the other part of this, GF. If they are similar equals proportional. So GF, so we did HG and DC. Now we're doing GF, which is 6, and CB, which is 4, which gives us 3/2. Are 4/3 and 3/2 similar or equal? They're not, so it's not similar. Now look at HG, 4, over PO, 5, and compare that to GF and the corresponding side ON. Then of course reduce it reduces to 3/5, which is not the same, not similar. HG once again is 4. ZY this time is 6. And then GF again is 6. And 9, which reduces to 2/3. 4, 6 also reduces to 2/3. Since they are equal, since 2/3 equals 2/3, they are proportional. Therefore, they are similar. So rectangle WZYX, or I guess you could have said WXYZ, is similar. So now we have to set up the proportions for this. AC and DF. Well, AC is 4, DF is 5. Well, now we're going to compare the other one, CB, FE, which is 3/12. And when we reduce this, this becomes 1/4. This is 4/5. And you end up with not similar. Now, I'm going to do this one over again. All right, these are not similar. But I want to show you one other way, one thing that we need to take a look at. When we are looking at corresponding sides. So the answer to this, they are not similar. But when looking at 3 and 4, 3 is the smaller number. So for a right triangle, CB should match with the other smaller number. All right? So our proportion should be CB over DF, which is 3/5. Then the bigger number should be compared. So AC over FE is 4/12, which reduces to 1/3. So no matter what, for this one, not equal, not similar. All right. So rewatch this video. This is something that can be quite complicated. So rewatch the video if you need to, but definitely do your CYUs, which are on page 505, and it's going to be exercises 1 to 8 all. You need to do these proportions. You have to. Good luck.